Good morning. My name is Devesh Kumar Srivastav, and I am a professor in Department of Information Technology at Manipal University, Jaipur. Today, I am going to present my paper in the conference, International Conference on Recent Trends in Machine Learning, IoT, Smart Cities and Application, which is held in the Hyderabad, India. The topic of my paper is detection of age and gender from facial images using convolutional neural network. This is the abstract of my work. We use this convolutional neural network in my paper to classify the gender and ages from the facial images. We took some samples of the age group 0 to 2, 4 to 6, 8 to 12, 15 to 20, 25 to 32, 38 to 43 years, 48 to 53 years, and 60 to 100 years from 8 nodes. It is very difficult to find the actual age, and from some images which already have some lighting or expression or pattern or makeup. So therefore, rather than using the regression, we consider it as a classification model. So the automatic age and gender detection has become increasingly important, particularly in the social network and social media, which are rapidly grown. So this demonstrates that the use of deep neural network is increasing significantly to showcase the performance of observed accuracy for age and gender classification, which are higher than other existing claims. This is the introduction part. CNN model have various applications, but it comes from the pattern recognition. In this paper, we use in detecting age and gender. The models are as follows: deep convolutional neural network, ResNet, DenseNet, Exception, AlexNet, VGG neural network. Several concerns about age and gender classification. However, some remain unresolved. So despite of recent advancement made by the computer vision community in new techniques that improve age and gender prediction of unfiltered real-life faces, many strategies have been forward in recent years to solve the classification problem. So we can use the deep learning-based algorithm in my work. This is the literature survey as you are seeing in the screen, but due to short time, we don't discuss the part of the literature survey, but yes, we have covered some papers, which is a part of my paper, as you are seeing in this screen. So we are going to discuss again the methodology. We have taken some data set borrowed from the Kaggle repository, which is available on the online. This data set is a collection of face images and text file, which is consisting of the 19,370 total faces images. This data set is the benchmark for face images and include many image conditions in the real world, such as noise, light, position, and presence. The photographs are collected from the Flickr albums. In this data set, there are images of every age group. Here are some samples as you are seeing in these screenshots. So this is our flow work. So first we have to pre-process the data. That means we can filter the images by removing some incorrect images or some disturbing images, or we have to pre-process the images. We have some modify the images so that images can be fit for our model. So in this flow work, first we have to input the images, then filter the original images by removing some noise. By removing some noisy images, then we have to extract the feature. Then we have saved the file in CSV format. Then load the CSV files into our pandas. Then we can build the model using CNN using training data set. Then we have to testing model using testing data set and validation data sets. Then we check the results in the form of accuracy and performance of the model. Then we can apply the performance matrix and collect the results in the table. We have built up this model. We can use the different layers as you are seeing in this layer. These are the convolution layers, some dropout layers, some maximum pooling layers, fully connected layers. And when we have to execute the images, then images pass through from the different layer, and finally we get the output. So when we have to build up this model, Then first layer is the conventional layer. In this layer shape, the input images of 2 cross 27 cross 227 cross 3. Filters. Filters are 96, kernel size is 7 cross 7, strides in 2 cross 2, threading is valid, and activation is ReLU function. So again, we can add the maximum pooling layer, which pool size 2 cross 2 and size 2 cross 2. Then we can adding a normalized layer. So in this way, we can go through all the steps to build our model, as you are seeing in our work. And we can use also the algorithm. This algorithm is first we have to use the face images from training data set. Then we can pre-process the images to obtain cleared and filtered images. We have resized the images, and we can implement all the resized images into NumPy array and implement to the test and train data set. Then we have to define the CNN model using a sequential model. That means data will travel sequentially from one layer to the other without any jumps and splitting. We have to train the model. That means more epochs are likely to give better accuracy. So with the set of images to classify the age and gender respectively, test the model with testing image data set. Then we have to classify, fit the model using LM optimizer, and in this final step of the proposed framework, first perform the gender classification or prediction on the test images. We have to find the accuracy for gender classification, then perform the age classification prediction on the test images. We have to find the accuracy for age and gender classification. So you can see that here some sample of the images. Then we can execute some sample of images using the CNN model. So this is our CNN model. We can pre-process the images, then we can execute these images into the model. Then model generate the output as the gender is male or female. So these are the different layers from which these images has to be executed, and they can modify the images, execute the images, and find the output in terms of the gender is the male or female. This is the confusion matrix for gender classification and detection. We have used the matrix as a precision, recall, F1 score, and support. And the matrix is accuracy, macro average, and weighted. So we can got the support 53.38, 52, 36, 52, 36, 52, 36, which is the confusion matrix for age classification detection. And again, we have got the confusion matrix for age classification. So this is the same matrix, and we got the support 52.38, 52, 5236, 5236, 5236 based on the value of the precision and recall. For gender detection, precision, recall, F1 score support is 1.00, 1.00, 1.00, and 5236 respectively. And for age detection, precision, recall, F1 score support is 0.00, 0.00, 0.00, and 5236 respectively, which is the results. So we have plotted the graph against the data table. So you can see that we have plotted the graph against testing accuracy for the training accuracy against the accuracy versus loss. So x-axis represent the loss and y-axis represent the accuracy. So you can see that there are two types of the graph which represent the testing accuracy and training accuracy. Orange color represent the testing accuracy, training accuracy, and blue color represent the testing accuracy. So you can see that training accuracy, which start from the x-axis, which start from 0 and go to the near about 0.5 ever and 20. So this is the coordinates of the x and y in terms of 0.5 plus and 20 plus. So if you can see the testing accuracy also starts from the 0.3 and goes to the on the x-axis at 20 coordinates. So similarly, this value is something higher than the previous value. And similarly, if we see the training loss and testing loss graph, the training loss and testing loss, you can see that the blue color represent the testing loss and orange color represent the training loss. So this is the graph which represent the higher value of the training loss and the testing loss with respect to the training loss and testing loss graph. Finally, we observe the results in terms of the accuracy of age and gender selection. You can see that our experiment study give the better results comparatively to the existing research paper, which is cited in the reference 9, 10, 11, 13, 12, 15, and 14. So it observed that the value as you are seeing in this table, but my experimental study gives some better results comparatively to existing results. So it can modify the classification of age and gender selection. So this problem of gender and age detection and classification is closely related to the face detection. Current approaches use the neural network architecture for age as well as gender prediction. In this work, we detected and predicted the age and gender of images using the conventional neural network. Based on this CNN architecture result, the experimental study performed better accuracy compared to the others as shown in this table and figure. Therefore, the model detected the age and gender using various images in an efficient and accurate way. So these are the reference. We use this reference in our paper. Thank you very much. If you have any question or concern, then you are welcome. Thank you very much.